Hello students, good morning everyone. So now in continuation with the previous video on module 1, so I will go to the second video of module 2, module 1, so that is data warehousing, a multi-tier architecture we are going to discuss in this video lecture, and we are also going to discuss the comparison between the OLTP and OLAP. Then we are going to discuss what are the different data warehouse models, that is enterprise warehouse, data mart and virtual warehouses. Okay, coming to the major differences or major distinguishing feature of OLTP and OLAP are the major differences between the OLTP and OLAP. OLTP is online transaction processing, whereas OLAP is online analytical processing. So now we have so many characteristics features that we need to discuss over here. Around 15 different features, more than 15 features we are going to discuss, and with respect to those features, and we are going to analyze what is with respect to an OLTP and what is with respect to an OLAP. So, first feature if you take into consideration is characteristic feature. So, OLTP is operational processing, as OLAP is informational processing. Operational processing means it deals with the online transactions that are happening, the current up to date data. Day to day, whatever it is happening online, so the transaction, monitoring all those things is one of the characteristics of an OLTP. Whereas OLAP deals with the informational processing. As I told in the previous class, previous video lecture, that OLAP collects the data from different external sources, that is multidimensional data from different sources, combine them and then analyze. So, OLAP completely deals with analysis of the data. The second feature is the orientation. So, here OLTP deals with the transaction processing, that is transaction, whereas OLAP is analysis of the complete data. Now, who uses OLTP and who uses OLAP? So, for which part of the group of the organization this OLTP is useful, and for which group of the people this OLAP is useful? So, OLTP is used by the clerks of an organization, DBA, database analysts and database professionals, whereas OLAP is used by the knowledge workers, example managers, executives and analysts. So, here OLAP is used by the knowledge workers, that high level executives are using, because this deals with the decision making strategy over here. Because of the decision making capability of the OLAP, or OLAP helps in making the decision with respect to future market conditions. Okay, so that is used by the executive levels. So, what is the function of the OLTP? OLTP is a day to day operation, day to day transactions that are happening, performing those, and if there are any queries in the transaction, resolving those queries is the function of the OLTP. What is the function of the OLAP? Long term information requirement decision support system. So, here a historic data is kept into the data warehouse, a data from last 5 to 10 years of a huge amount of data is kept, and this historic data is used to analyze based on the requirements, and it will help you to take or support the decision. Database design. So, how database is designed in a OLTP system? So, in a OLTP system, ER based entity relationship diagrams are used, application oriented, current guaranteed up to date type of design, entity relationship based and application oriented type of database design we are using in OLTP. Whereas, the database design in an OLTP system is either a star or snowflake and it is subject oriented. What is a star and snowflake database design? We will see in the further video lectures in detail. So, understand OLTP is an application oriented, whereas OLAP is a subject oriented. What type of data is involved in OLTP? So, current day to day data, current data is involved, guaranteed up to date data is involved in OLTP system, guaranteed up to date, whereas OLAP deals with the historic data, that is accuracy is maintained over time. So, a historic data of last 5 years or 10 years we are using over here, accuracy maintained over time. Now, another feature of the OLTP and OLTP is summarization, that is primitive and it is highly detailed data, whereas the summarization in OLAP is normally summarized and it is consolidated data. OLTP contains highly detailed data, whereas OLAP contains a consolidated data. Why consolidated? Because it is the data is coming from multiple sources. Next, another characteristic, another feature is the view, how we are going to view the data. So, here OLTP deals with the detailed data, it is a flat relational data, whereas OLAP is a summarized data and it is multidimensional. OLTP is a flat relational data, whereas OLAP is multidimensional data. Next feature is unit of work, it is very short and simple transaction, very short query and it is just a simple online transaction, whereas in OLAP is a complex query. So, access to the data in OLTP, here you can read and write a data in OLTP, whereas in OLAP you can only read, mostly read type of operations can be done. Focus is data in into an OLTP, whereas OLAP is information out. Here data is an input to the OLTP and for an OLAP the information is out. Based on the information that is coming from OLAP, a particular decisions are taken which will decide what are the future strategies of a company in future. Then operations. So, here index or hash on primary key type of operations we are doing, whereas in OLAP lot of scans of data we will be doing, scanning the data again and again to get the detailed information, and that data has to be such that a proper decisions can be taken. Whereas, how many number of records you can access in OLTP? In OLTP you can access tens of amount of data, whereas in OLAP you can access millions of the data. Next feature is the number of users. How many number of users can use the OLT at a time is thousands, whereas in OLAP is hundreds. What is the size of database in OLTP? GB to higher order GB. In OLAP is more than terabytes. Priority, which is given more priority in OLTP. Here performance and availability is given more priority, because as you are dealing with the online transaction, the performance of the system should be high as well as the system should be highly available. Whereas OLAP, it should be highly flexible and it should have an end user autonomy. Metric, transaction throughput, whereas for OLAP is a query throughput and the response time. Next, coming to the data warehousing, a 3-tier data warehouse architecture. So, as you see in the figure 1, figure 1 represents a 3-tier data warehouse architecture. So, this total architecture is having 3 tiers along with the data. Why it is called as 3-tier? It is having a top tier, middle tier and bottom tier. Top tier is front end tools, that is like data mining, analysis and query reports. Middle tier we have is OLAP servers, and at the bottom tier we have data warehouse servers, and last is the data, operational data and data from external sources. Okay, so the data from external sources and external sources is taken, it is extracted, it is cleaned, it is transformed, it is loaded and refreshed, and that data we are doing it to the bottom tier. So, bottom tier is data warehouse server, that is having different modules like monitoring, administration, data warehouse, data marts and metadata repository, whereas the middle server contains only the OLAP servers. Operational data or the data from external sources, after extraction, cleaning and transformation and loading, it is given to the bottom tier, that is it is given to the data warehouse server. So, from that data warehouse server, it is given to the OLAP servers. These OLAP servers analyze the data, predict the future conditions what can happen, and then the analysis is done, then data mining is done, and then reports are generated, query reports are generated. We will see one by one. Coming to the bottom tier, what is the bottom tier? Data warehouse server. So, this is what the bottom tier. So, bottom tier is a warehouse database server that is almost always a relational database system. So, the bottom tier is based on relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational and other external sources. So, here backend tools are used. Okay, so, why these backend tools are used? Backend tools and utilities are used in order to feed data to the data warehouse servers. Okay, so, that data is coming from the operational databases and from the external sources. What is this data contains actually? This data contains the customer profile, information provided by the external consultants. So, this data is taken from the operational database and external sources. We extract, we clean, we transform, we load and refresh, and we give as an input to the data warehouse server. So, now what these tools will do? That only I told. These tools and utilities perform data extraction, data cleaning and transformation. Why need to do this all these things? To merge similar data from different sources into an unified format. The data coming from the different sources, sometimes the same type of data may be coming from the different sources. Then what we need to do? We need to merge the similar data from different sources into an unified format, as well as load and refresh functions. Why to load it? To update the data warehouse. Then the data are extracted using application program interface known as gateways. How data is extracted? The data is extracted using application program interface known as gateways, and this gateway is supported by an underlying database management system, and it allows client program to generate SQL code to be executed to a server. Okay, so, that is the tools and utilities perform data extraction, cleaning and transformation, example to merge similar data from different sources into a unified format, as well as to load and refresh functions to update a data warehouse. The data are extracted. How data is being extracted? As already told, data are extracted using application program interface known as gateways. And this gateway is supported by an underlying database management system, which allows client program to generate SQL code to be executed at the server. So, examples of this gateway include ODBC, that is Open Database Connection, and one more is OLEDB, Open Linking and Embedding for Databases, Object Linking and Embedding for Databases. This is developed by the Microsoft, and JDBC, Java Database Connection. This tier also contains a metadata repository which stores information about the data warehouse and its contents. What is the use of this metadata repository? The metadata repository contains information related to what is present in the data warehouse, its content, what is present in the data warehouse, which gives the information about the data warehouse and its content. Next, coming to the middle tier. So, middle tier is an OLAP server. What is a middle tier? Middle tier is an OLAP server that is typically implemented using either a relational OLAP, that is ROLAP, that is if it is OLAP is relational, then it will be called as relational OLAP, that is ROLAP, ROLAP, or if it is multidimensional, then it is called as MOLAP, multidimensional OLAP or MOLAP. That is an extended relational DBMS that maps operation on multidimensional data to standard relational databases. Why it is required? Why ROLAP or this ROLAP, what is this ROLAP? ROLAP is an extended relational database DBMS that maps operational and multidimensional data to a standard relational database operations. So, in order to map a multidimensional data to the standard relational operations, we are using relational database modules, that is ROLAP. What is multidimensional? Multidimensional OLAP model, that is a special purpose. A multidimensional OLAP model, that is it is a special purpose server that directly implements multidimensional data and operations and reporting tools, analysis tools and data mining tools together. Why we require all these things? A multidimensional MOLAP model, that is a special purpose server that directly implements. What it directly implements? It implements directly multidimensional data and operations, reporting tools, analysis tools and or data mining tools. Why it is required? For trend analysis of the data, prediction and so on. Next, coming to the top tier. The top tier. What is the top tier now? The top tier is the front end client layer, which contains query and reporting tools. What it contains? It contains query and reporting tools, analysis tools and data mining or trend analysis tools. It is the bottom tier. So, the top tier is the front end, which again contains query and reporting tools and analysis tools and data mining tools. So, multidimensional MOLAP model, that is a special purpose server that directly implements multidimensional data and operations. Multidimensional data and operations. Now, coming to the another part, data warehouse models. So, data warehouse models, there are 3 data warehouse models. One is the enterprise warehouse, data warehouse, enterprise warehouse, data mart and virtual warehouse. From the architecture point of view, there are 3 data warehouse models. So, one is the enterprise warehouse, the data mart and the virtual warehouse. An enterprise warehouse, what an enterprise warehouse does and why it is required. An enterprise warehouse collects all information about subjects spanning the entire organization. An enterprise warehouse collects all of the information about subjects spanning the entire organization. It provides corporate wide integration. Remember what enterprise warehouse does. It collects all the information related to the entire organization. It provides corporate wide integration. Corporate wide integration it provides. From where? Usually from one or more operational systems or from external information, and is cross-functional in scope, and it is cross-functional in scope. It typically contains a detailed data as well as summarized data. Enterprise warehouse contains 2 types of data. One is summarized data as well as detailed data, and this data can range from few gigabytes to hundred of gigabytes or terabytes or beyond. A huge amount of data is present in an enterprise warehouse. An enterprise warehouse, data warehouse may be implemented on traditional mainframes or computer super servers or parallel architecture platforms. It requires extensive business modeling and may take years to design and build, but the thing is that if you want to build an enterprise warehouse, what is required? It requires extensive business modeling and may take years to design and build. Next, coming to the data mart. A data mart contains a subset of the corporate wide data that is of a value to a specific group of the user. The scope is confined to a specific selected subjects. For example, marketing data mart may confine its subject to customer, item and sales. Now, marketing data, what marketing data should have? In a data mart, if I am having a marketing data, what it should contain? To which subjects it should be confined? It should be confined to the customers, to the items and sales. The data contained in data marts tend to be summarized. Data marts are usually implemented on low cost departmental servers that are Unix or Linux or Windows based. Data marts are usually, so on how we can implement a data mart. Enterprise warehouse are implemented using mainframes or supercomputers or parallel architecture platforms, whereas data marts can be implemented on a low cost departmental servers that are either Linux or Unix, Linux or Windows based. The implementation cycle of a data mart is more likely to be measured in weeks rather than months or years. So, how much time is required to build a data mart? Just from a few weeks to a few months or a year, whereas To build an enterprise data warehouse, we require many years. So, the designing complexity is much less in data mart as compared to the enterprise warehouse. Depending upon the source of the data, data marts can be categorized as independent or dependent. Again, there are two types of the data marts over here. Depending upon the source of the data marts can be categorized either as independent data mart or dependent data mart. Independent data marts are sourced from data captured from one or more operational system or external information provider, or from data generated locally within a particular department or a geographic area. Remember, if I collect a data, independent data mart is one which is taking data from external information providers or from operational systems, or the data that is generated locally within a particular department or within a particular geographical area, whereas dependent data marts are sourced directly from enterprise data warehouse. Okay, however, it may involve complex integration in long run if its design and planning were not enterprise wise. Regarding the data mart. Okay, so that is all I discussed. Depending upon the source of the data class can be categorized into dependent and independent data marts. Independent data marts are sourced from data from one or more operational systems or external information providers, or from data generated locally within a particular geographical area, whereas dependent data marts are sourced directly from the enterprise data warehouse. Next, coming to the virtual warehouse. What is a virtual warehouse? A virtual warehouse is a set of views over operational databases. A virtual warehouse is what? It is a set of views over operational database. For efficient query processing, only some of the possible summary views may be materialized. So, here for efficient query processing, what we are doing? Only some of the possible summary views may be materialized. A virtual warehouse is easy to build, but requires excess capacity on the operational database servers. It requires a virtual warehouse is easy to build, but it requires excess capacity on the operational database servers. Now, coming to the another point, a recommended approach for data warehouse development. Before I go into detail of this data warehouse development, let us understand what are the pros and cons of the top down and bottom up approach to develop a data warehouse. What are the pros and cons if I develop a data if I follow an approach from top to down or from bottom to up? To build a data warehouse, the top down development of an enterprise warehouse serves as a systematic solution. Top down approach development of an enterprise warehouse serves as a systematic solution and minimizes integration problems. If you follow a top down approach, if you utilize in order to build a data warehouse, then it will be serving as a systematic solution and it minimizes integration problems. However, some limitation. What is that? It is expensive. If we follow a top down approach, however, it provides systematic solution and it minimizes integration problem. That is the advantage, but what is the problem? It is expensive, takes a long time to develop, and lacks flexibility due to difficulty in achieving consistency, and consequences for a common data model for entire organization. Now, coming to the bottom up approach to the design, development and deployment of independent data marts. If I follow the bottom up approach, what is the advantage? It provides flexibility, it provides low cost, and it is rapid return of investment. What are the advantages? It provides flexibility, it is a low cost and rapid investment, rapid return of investment. It, however, can lead to problem when integrating various disparate data marts into a consistent enterprise data warehouse. So, the only problem or only limitation with the bottom up approach is integrating with the data. A recommended approach for development of data warehouse system is to implement data warehouse in an incremental and evolutionary manner. Now, what to do? Both the methods, top down and bottom up, both are having advantages and limitations. Now, which method we should follow? Now, the recommended method for development of data warehouse system is to develop a data warehouse in an incremental manner, in a evolutionary manner as shown in figure 2. What is here? First, a high level corporate data model is defined within a reasonably short period of time. Now, what we are going to do here? So, now we are going to first define a high level corporate data model. What we are doing? We are going to define a high level corporate data model. How much time? Within a reasonably short period of time, such as within 1 or 2 months, we need to define a high level corporate data model, and that provides a corporate wide, consistent, integrated view of data among different subjects and potential users. This model should provide a corporate wide data, it should be consistent, it should be integrated view of data among different subjects and potential users. The high level model, although it will need to be refined in further development. Now, we need to again go for model refinement. So, once you define a high level corporate model, then again we need to go for model refinement. So, we need to go for model refinement. So, you can take the data mart and data warehouse enterprises. Now, we are giving the data mart to the data enterprises, and we will check what is the output of the data mart, or what is the output of an enterprise data warehouse. If they are as expected, if they are, it is well and good. If they are not as expected, then we will give some input back from enterprise data warehouse or from database or distributed data marts for model refinement. And this high level model is again further refined in a further development process, and using the feedback from the data marts and enterprise data warehouse and from the distributed data marts, and this will greatly reduce future integration problem. So, once you develop a high level corporate model and give us an input to the enterprise data warehouse, to the data marts or distributed data marts, we are taking back the inputs and we are model again, we are redefining the model. If you do so, it will reduce the problems while integrating in future. Second, independent data marts can be implemented in parallel with the enterprise warehouse based on the same corporate data model set noted before. So, now data marts and enterprise data warehouse can be parallelly developed based on the same corporate data model. Based on the same corporate data model, we are able to do that. And third is distributed data marts. Now, coming out to this, distributed data marts can be reconstructed to integrate different data marts via hub servers. So, distributed data marts can be constructed again. So, distributed data marts can be constructed to integrate different data marts via hub servers. Finally, a multi-tier data warehouse is constructed where the enterprise warehouse, a multi-tier data warehouse. Finally, we are going to build a multi-tier data warehouse is constructed where the enterprise warehouse is the sole custodian of all the warehouse data. Now, who is the custodian? Enterprise data warehouse is the sole custodian of multi-tier data warehouse, which is then distributed to the various dependent marts. So, in this video lecture, what we have discussed up till now is what is the difference between OLAP, online transaction processing, and online analytical processing, the comparison between them with respect to the features like characteristics, orientation, user, function, and so on. Then we studied a data warehouse, a multi-tier architecture. So, what are the different tiers? One is the bottom tier, top tier, and the middle tier. So, top tier is front end tool, middle tier is OLAP server, and bottom tier is data warehouse. And then we discussed different data warehouse models. It is enterprise warehouse, data marts, and virtual warehouse. Then we also discussed virtual warehouse, we also discussed a recommended approach for data warehouse development. So, with this summary, I would like to end this video. In next video lecture, we will see the processes like extraction, transformation, loading of data, and what is metadata repository. So, we will stop over here. Thank you one and all.